Okay, this is going to be a lesson on Student Learning Task 2, calculating probabilities of events with two-way tables. First thing I'd like you to do is get out your packet and open up to page 5 and complete numbers 1 through 3. Just as a note, we removed SLT 1 and changed it, so you're not going to know what event card 1 is. So just make a note that event card 1 is spinning a spinner with 1, 2, and 3, and these are equal, sections on the spinner. And I have random cards. I have 4 cards that are blue, and I have 2 cards that are red, and the blue cards are marked A, B, C, D, and the red cards are marked E and F. So I am spinning the spinner, and I am selecting a card. Okay, at this point you should have worked on these 3 problems. So the first thing I'm going to do is just write out my sample space. I'm just going to kind of do it by making a table, just so I can kind of get an idea without physically writing out all the outcomes. So I have blue A, blue B, blue C, blue, oops, that's terrible, oh well, blue D, red, I don't know what that was all about, E, oh, because it was E I was thinking, red F. And so right away I see that I have 18 outcomes, all right? And it says, for a chance experiment, why is the probability of spinning an odd number and randomly selecting a blue token the same as the probability of an event spinning an even number and randomly selecting a blue token? Well, there are 4 blue tokens. 8 of them, I've got 8 outcomes, 1, 2, 3, 4, 5, 6, 7, 8 ways I can do odd and blue out of 18. And then the probability of even and blue is only going to be these 4. So that is why they are not the same. So it's odd and blue is twice as likely to occur as even and blue. I'm going to hold on to this. That's kind of handy. So question 2 asks, why is the probability of spinning an odd number and an odd number and selecting a blue token? So probability of odd and blue. Well, we know from up above that that is these 8, 1, 2, 3, 4, 5, 6, 7, 8 out of 18. Now we want to know, how is that different from the probability of odd or blue? Okay, so if something is odd or blue, if it's odd and blue, that qualifies. So I'm going to check off those 8. So, but I could also add the evens in because they are blue. It's odd or blue. But I also could add in 1 and red E, 1 and red F, 3 and red E, 3 and red F. So I actually, all but 2, so that's going to be 16 out of 18. And so the answer is, here are the probabilities. Odd or blue doesn't require both events to occur. The events odd and the events blue, they both don't have to occur. Only one of them has to occur. All right. Number 3 says, if one of the red tokens is changed to a blue token, what is the probability of spinning an odd number from spinner 1 and randomly selecting a red token from the bag? So the first thing I'm going to do is I'll do this one in black, and I'm going to cross off E, and I'm going to make it blue. All right, so if I want to spin an odd number and select a red token, it's just those 2 events. So I've just got 2 out of 18, or 1/9. Again, reducing fractions, if we're doing a comparison like we were in A and B, in 1 and 2, definitely reduce. Otherwise, you definitely do not reduce so we can compare. Otherwise, reduce. All right, so here are the homework answers from last night. These were posted on Drive, so I'm just going to run them up real quick. So if you want to just check them over. Okay, so we're going to go ahead and start looking at two-way tables. Go ahead and turn to page 7 in your packet. take a moment and read through the explanation and number 1. All right. Do I think the school board should recommend building a new high school? Well, when I look at the overall yeses, total yes. So I have a total yes. Now I gotta have to add them up. So if I go 119 plus 154, I've got 273 people out of 515. Now, that fraction is like perfectly acceptable, but it's hard to make a conclusion from an odd fraction. So when I do that, and I see that 53% would like a new high school, yes. Majority of people, P-E-O-P-L-E, surveyed want a new school. Okay. An eligible voter is picked at random. If the person is 21 years old, do you think they would indicate they would want a new high school? So the first thing I'm going to do is I'm going to write this out properly. I'm going to say, okay, I know the person is 21 years old, so I'm going to say given 21, yes. So my denominator for this, for the 21-year-old people, so I'm going to go here. So that's going to be 75. And of those 75, this male and female thing is annoying. That would be 61. And again, it's always good to have a percentage in these situations. They're a little more understandable. I get 81%. Yes. 81% of those surveyed who are 18 to 25 would like a new school. All right, an eligible voter is picked at random. If this person is 55 years old, would they want a new school? So I'm going to write this as the probability of yes given 55. And so for 55, I'm going to go in the 41 to 65 category, and there are 149 of them. And of those 149, I've got 66. 66 divided by 149 is only 44. So I would say no. Only 44% of people in that age range want a new school. All right. So on page 8, we finally realized that maybe our categories are a little wonky. Do we think, it says, why do you think the survey classified voters this way? Well, if you think about it, people who are 18 to 25 are just out of high school. People 26 to 40 and 41, maybe 41 to 65, I'm gonna say maybe, have school-age children. And then we have our retired folks. I'm kind of out of space, so I'm not going to comment on the retired people. All right. So this is what I meant. I was ahead of myself. We really do not need to know if they're male or female. So what we are now going to do in number 5 is to condense them down. And I have recopied that table for you right here so that you can see it. So we're going to say over here we've got 61 Over here we've got 113. And just go ahead and fill in those numbers real quick. Pause the video because I'm going to go fast. Okay, so now I have a better table to look at. All right, so a local news service plans to write an article summarizing the results. 3 are possible headlines. Is each headline accurate or inaccurate? Support your answer using the probabilities calculated in the table above. So go ahead and pause the video and take a look at these 3 headlines and decide if each one is accurate or inaccurate. So for the first one, I would say yes, it is accurate because as we figured out before, 53% support building a new school. Older voters are less likely to support building a new school. So it depends how you define older voters. If you decide that they are 41 to 65, that's out of these 149, 66 divided by 149, oh, we did that already, is 44%. And then 65 plus, let's see, what were they? 65, oh, we didn't do that. 65 plus, well, they're definitely less, so because they were only 33 out of 88, which is 38%. So I would say that this is also a good headline. Less likely. Younger voters are not interested. Okay, clearly this one is a big old no because the younger voters, we had 61 yeses out of the 75 of them, which is clearly more than half. All right. All right, again, I've got our table recopied on page 9. So you don't have to flip around. I want you to make a little note on page 9 that we find an expected value by multiplying the probability of the event by the population we know. So the school board decided to put the decision on whether or not to build the new high school up for a referendum in the next election. So they're kind of like asking people to vote. At the last referendum regarding this issue, only 25 of the eligible voters and ages 18 to 25 voted, 110 of 26 to 40, 130 of 41 to 65, and 80 of the 66 plus voted. If the voters in the next election turn out in similar numbers, do you think the referendum will pass? So, what I'm going to have to do here is calculate how many votes I'm going to get. So I'm going to write this out first. I need the probability of getting a yes vote from my 18 to 25s, and I'm going to multiply that by the 25 eligible voters who voted. Then I'm going to add to that the probability of getting a yes vote given that someone is 26 to 40, and I'm going to multiply that by 110 to see how many yes votes I get. Then I'm going to add the probability of a yes vote given that someone is 41 to 65, and I'm going to multiply that by 130. And yes vote given that they are 66 plus, and there were 80 of them. Okay, and that's going to tell me how many yes votes I get. So here we go. The probability of being a yes voter if you are in this age group, so I've got 75 in that age group, and 61 voted yes, times 25. Then I've got, there were 203 people surveyed, and 113 of them would say yes. That's the probability times the population. 66 say yes out of 149 times the population, and then 33 out of 88, and I'm expecting 80 older voters to show up. Now, if I put this all in my calculator to the nearest person, I get 169. Now, that means I have 169 yes votes that I am expecting. So out of how many is the question. So what I'm going to do, if you add up these four numbers, in the last election, there were 345 voters. So based on these 345 voters, I'm expecting 169 of them to vote yes. So this comes out to about 49%. So I would not expect this referendum to pass. Is it possible that our prediction is incorrect? Yes. More young people could show up to vote, which would push my prediction over 50%. This is really close. I mean, this is not like, if it was 32%, I'd be like, ah, too bad, you guys aren't getting a new school. But it's only 49%. It's close to 50. If more young people show up to vote, you're getting a new school. All right. Ladies and gentlemen, I super love this question. So this is what I would like you to do. In your groups, I want you to pause the video or on your own, read through page 10, and fill in any cells you think you know the answers to. So pause the video. Okay. Again, I'm going to use expected value. If I know that the probability of having asthma is 0.193, over here for cell number 3, oh, look at that. This is number 9. The probability can be used to calculate cell 3. Because I can say, all right, here's my 0.193. If I multiply that by 1,000, I'm expecting 193 people to have asthma. So if I have at least one household member who smokes is 0.421, that's going to be cell 8. And so 0.421 times 1,000. All right. All right, so go ahead and on page 29, let's just recopy those numbers real quick. So we've got 193 and we've got 421. So I don't have to keep flipping back and forth. It says, in addition to the previous given probabilities, the probability that a randomly selected student that has at least one household member who smokes and has asthma is 0.12. So which cell is that going to be? Now, if we were still numbering the cells, we would see that that's cell 2. So we're going to go 0.12 times 1,000, and I have 120 people. And I want you to just pause and think about these numbers for a second, and do they actually make sense in the real world? And hopefully you said yes, because if someone in your household smokes, you are probably more likely to have asthma than people who don't. Number 12 says, complete the two-way table by calculating the values of the other cells in the table. So immediately I can just subtract 193 minus 120, and I've got 73 students here. I can do 421 minus 120, and I have 301 students. I can do 1,000 minus 193, and I've got 807. I can do 1,000 minus 421, and I get 579. And then this one, I mean, you have a choice. Like, you can subtract one of two ways. You can do 579 minus 73. You can do 807 minus 301, whatever you like. Either way, you are going to get 506. And this is the table that we are now going to use to calculate some probabilities. This page, page 11, is probably the most important page in this entire lesson. There is no fluff. It is very straight to the point. And we are going to be very careful with the way we write these out. So here we go. Based on your two-way table, estimate the following probabilities as a fraction and a decimal rounded to 3 decimal places. A randomly selected student has asthma. This is a given. So I'm going to immediately start with P of something given. I'm going to call this, so I'm immediately going to call this event A. This is going to be A prime. This is going to be S, and this is going to be S prime, just to make my life a little easier. So I know that the student has asthma. What is the probability that this student has at least one household member who smokes? So what is the probability that they have someone who smokes, given that they have asthma? So we're going to start with how many people have asthma? 193. That's going to be my denominator. Of those 193 people, how many of them have someone who smokes in their house? 120. When I divide this out to 3 decimal places, I get 0.622. All right, so I want you to read letter B and see if you can set up the notation in a similar way that I did for letter A. All right, so you should have tried this on your own, and I know that they do not have asthma. What is the probability that they have at least one household member who smokes? So how many people do not have asthma? 807. And of those 807, how many of them have someone who smokes? That's 301. Because here's the do not have asthma row, and of those 807, only 301 have a smoking member in their household. And when I divide that out, I get about 373. Okay, again, see if you can write this out with symbols, and now also find the proportion. I know a student has a household member who smokes. What is the probability they have asthma? So there are 421 households that smoke, that have a member who smokes. The household itself doesn't smoke. I don't know, maybe it's on fire. Of those 421, how many have asthma? $120. When I put that in, I get 0.285. Do I think whether or not a student has asthma is related to whether or not this student has at least one family member who smokes and smokes? So this is what I'm going to do. I'm going to think the probability that someone has asthma is 19.3%. But if I know you have someone who smokes in your house, it jumps up to 28.5%. Because of this, I would say yes. Having someone who smokes in your house means you are more likely to have asthma than someone who doesn't. And again, you should write this out in a complete sentence. All right. There is a slight typo in the homework. Please make sure you change page 13. Make sure it's correct. I'm not sure if we changed it in the packet or not, but there was a typo on the original SLT. Now Waldo's asking about their library services. This is a great homework that I'm definitely checking tomorrow, page 13 to 15. I'm going to jump ahead, so if you want to just check your answers, you can look at those.